Transformer Calculator is a new Android app available from Snappy Appz. This software is available on the Google Play Store as a free ad-driven version and a paid ad-free version. The software is designed with electrical engineers and electricians in mind and was created by tradesmen who work in the field. Transformer Calculator is a very comprehensive package that supports multiple jobs and multiple transformer calculations. We highly recommend you watch this tutorial in its entirety so that you can get the most out of Transformer Calculator. While Transformer Calculator has many handy modules, such as a full-featured construction calculator and a conversion app, in this tutorial we will be concentrating on the core of the app, the job module and the transformer module. With that said, let's take a look at the app. When you first come into the app, at least the first time you load it up, you're going to want to go into the settings. So go ahead and click on the gears or the settings label here. And within these settings, you're going to want to concentrate on the code version. You're going to want to change your code version to what applies to you. So there's two options here. You can choose from the Canadian Electrical Code 2018 or the National Electrical Code 2014. Typically NEC is for the United States and the CEC is going to be for Canada. So I'm going to leave it on the CEC for us. And then we're going to back out of here, which will take us back to the main menu. The next thing we're going to want to do is go into the Jobs module, which is the hard hat icon. So go ahead and click on the Jobs module. And this will bring us into a list of our jobs that are all saved. When the first time you come into the app, all you're going to see is a default job. But we can easily rename that to an actual job we're going to work on, or we can add new jobs with the plus button up here in the right. So I'm going to go ahead and, just to show you, set up 3 jobs. So we'll hit the plus twice. We'll name them Equitable Insurance. It's going to be one of our jobs. We'll name another one RRR Steel, and then we'll just rename the default job, and we'll rename it DELSA Incorporated. Now we have 3 jobs set up. So the arrow on the left is to select the job that you want to work on. So for this example, we're going to work on RRR Steel, so we'll select it. So now we have our 3 jobs set up, and we have our job selected that we want to work on. We're going to go ahead and back out of the Jobs module. Now that we have our jobs set up, we can go ahead and head into the Transformer module. We will do this by clicking on the picture of the transformer, or the label Transformers. Once in our calculator, the first thing you'll notice is that our RRR Steel job is selected and is shown up here in the title bar. Now let's go ahead and set up 3 transformers underneath this job. We'll do this by either clicking the icon of the transformer or the name of the transformer, which right now is default transformer. Now that we're in our transformer list, we can add 2 new transformers by clicking the plus button twice. We'll go ahead and rename them by clicking the name of each. And there we have it. We have 3 transformers underneath the job RRR Steel. We'll go ahead and select XFF1 to work on by clicking the arrow icon to the left of it. If you need to delete a transformer, simply click the garbage can to the right of it. Or if you need to start from scratch, hit the reset button up at the top. So let's go ahead and back out of here. And now we'll see that we're working under the RRR Steel job and we're working on transformer XFF1. So let's go ahead and take a look at the specs of our first transformer and set it up the way we want it. In the first section of the Specs tab, we're going to select our transformer type. We can select between a dry transformer or a non-dry, such as an oil-filled or an epoxy-filled transformer. For now, we're going to leave it on a dry type transformer. Then we'll select our configuration. There are several configurations here, but I believe the most common is delta to Y, so we'll leave it on delta to Y. In our second section, the transformer specs, we're going to select the specs of our transformer. We can choose to solve in multiple ways with the Solve With section. You'll notice here we're solving with kVA, which is why we have kVA listed down here, where we can type in the kVA of our transformer. We can also solve with a primary FLA or a secondary FLA, which can come in very handy if we know our secondary load and are basing our transformer size, kVA size, on the FLA of the secondary. But our most common is to solve kVA, so let's go ahead and leave it on kVA for now. We are going to solve a 600-208 transformer, just like it says here. If you need to change it though, simply click on it and type in your new value. For this example, we're going to solve just as it shows here, the default transformer, 600 volt, 208 on the secondary, a 45 kVA transformer. So our spec section is set up. Let's go ahead and scroll down to wiring and protection. Most of these options are optional. So, a lot of the time you won't need to do anything with this one. By default, we do not have overcurrent protection on our secondary. However, if you are going to use overcurrent protection on your secondary, you'll want to check the checkbox. This will seriously affect the size of your overload protection on your primary, and will add overload protection to your secondary, of course. We're going to leave this off for now, as typically I don't use overcurrent protection on my secondary. The impedance rating can usually be left blank. This is only relevant for transformers over 750 volt. So since we're using a 600-208, we don't need to do anything with this value. However, if you're doing a transformer over 750 volt on primary or secondary, you'll want to put in your impedance rating of your transformer here, as it'll affect your calculation. The third wiring and protection setting is overcurrent protection when choking. This will also only be applied when you're choking down your transformer. So if you're just doing a straight up calculation for 45 kVA and you're not planning on choking it down, you can ignore this. However, once you choke down your transformer, this is going to set your overcurrent protection according to this percentage. So often you will leave this at 100% if you want your overcurrent protection at 100% of your typed in choking FLA. In our example, we are not choking down the transformer, so we're going to leave this untouched. So now that we have our transformer all set up, all the specs set up, we can go ahead and start going into our calculated results for our primary, which is our primary tab up here, and our secondary side, which is our secondary tab up here. So let's go ahead and click on our primary tab. Once we click on our primary tab, the calculated results will come up for the primary side of the transformer. The first thing you'll notice is the power section. This will show our full load amps of our transformer, which is 43.3 amps for the specs transformer that we typed in our specs section. And it'll also give, just under here in small text, the 125% rating of your full load amps, which can often come in handy just for double checking your calculations for wire size. Then we'll notice our kVA. This is just the kVA rating we typed in since we chose to solve with kVA. These are green boxes as they're calculated results, so they cannot be modified. Any white box can be modified. So let's go ahead and go down to our overcurrent section. This is going to show us our maximum fuse and breaker amperage. So for this transformer, it's calculated to 60 amps. If we want to choke down our transformer, we can actually click on one of these and type in a new value. But this is the calculated value that transformer calculator has calculated. Underneath there, we'll see our current percentage of our FLA, which right now is 138%. So our fuse sizing is 138% of our FLA rating. Then you'll see maximum percent FLA. This is straight out of the code book and is 125% since we don't have secondary overcurrent protection. If you did have secondary overcurrent protection, this will typically be 300%. you will notice that our current percent FLA is actually over our maximum FLA, and that's because the codebook allows us to upsize our fuse to a common fuse size. So we've upsized, as there's no 43.3 amp fuse or 125% of that, we've actually upsized to 60 amps, which is actually 138% of our FLA, but is allowable by code since there is no, say, 56 amp fuse. So there's your overcurrent. So now we're going to go ahead and scroll down to our wire sizing. There's a lot you can do in wire because you can select your wire types and parallel runs, your metal you're using and such. But a lot of these values are calculated as well. Your wire size, which is number 8, AWG for your primary, is the calculated wire size. This can be changed, which you might want to do if the wire size is very close, right? So if you're bang on your FLA or 125% of your FLA, you may choose to come in here and up your wire size. Once you do that, you see it'll turn red, which is just showing you a warning that it's not a calculated result anymore and that it's actually a user modified result. If you need to get everything recalculated, you simply go into the menu up top and hit recalculate. And you'll see our result turns back gray, showing that it's a calculated result. Underneath that, it'll show our maximum ampacity of our wire. So this is the allowable ampacity of number 8 wire, based on all our other settings as well. You'll see if I change that to number 6 again, it'll of course go up. It's showing us the allowable ampacity of whatever wire is selected. Let's go ahead and recalculate to get that back to a calculated result. Next is your number of primary runs. This allows you to do parallel runs. We won't do it here, of course, because it's only number 8 wire, and parallel runs are only permissible on 3/0 and bigger. So we'll leave that at a single run of cable. Underneath that is your wire type and your metal type. This is going to affect your allowable ampacity of your wire and your calculated size of your wire. So right now we're at 90-degree wire, but as you can see, we can select from all the different wire types. So let's go ahead and bump our wire down to 75-degree wire. And you'll see our wire size has gone up since our wire temperature rating is now lower. So now we're at number 6. 65 amps is allowable ampacity. Next underneath that is the metal type. We can use a copper wire or we can use aluminum wire. If you select that, you can select between the two. Let's go ahead and choose aluminum just to see what happens. So now you'll see our calculated wire size went up again since aluminum wire is not rated for the same capacity as copper. So now we're at actually a number 4 wire, still at 65 amps allowable ampacity. Our bond size is a calculated value and is the bond that will be pulled in with our current carrying conductors. And it's been calculated at number 8. And that's it for wire. So let's go ahead and move down to our pipe section. This is very similar to wire, where it's mostly calculated results, but they can be modified. So right now it's suggesting a 1-inch pipe, or a 27mm pipe, which is our minimum pipe size. So again, if this is right on the borderline, you may want to modify it, and you can do so just by clicking on the pipe size, and you can put it up a pipe size, 2 1/4 inches. Once again, it'll turn red to show that you've modified it, and it's not a calculated result anymore. And once again, you can go up to the menu and recalculate to force the app to recalculate it. Pipe type is the type of conduit you'll be using. I have EMT selected, but as you can see, we have a wide range of conduit types in here, from PVC to rigid to liquid tight to pretty much everything. So I'm going to leave it on EMT, as that's typical. Underneath that is a calculated result that you can't modify, as it's green. And it's just showing the required number of wires you need in your conduit, which is 3, since we're using a delta primary transformer, and the maximum wire that can fit in this calculated conduit. So as you can see, our pipe is calculated quite nicely, because we can fit up to 4 wires in there, but we only need 3. So it's just a good reference to show you how snug your conduit is going to be. Underneath that is wire type. This is used to calculate conduit fill, so it's crucial that you have your wire type that you will be pulling into the conduit selected here. Right now, by default, T90 nylon is selected. However, there is a wide range of wires to choose from in here. All the wire types listed in your codebook. So let's go ahead and choose TW75. And now you'll see we're only allowed 3 of 3 wires in a 1-inch conduit. It's still 1 inch calculated. So in this scenario, you might think, well, that's a pretty tight pull. So this is a scenario where you might want to up your conduit size to 1.25 inch. And now you'll see it's much less. You'll see that we still need 3 wires, of course, in the conduit, but you can fit up to 5 of the calculated type in this conduit. And that's it for the primary side of the transformer. So now let's go ahead and take a look at the secondary results, which of course are quite similar to the primary, but based on the secondary voltage. So, as you can see right away, our secondary side is quite similar to our primary side. However, there are some small differences. First, we have our full load amps, of course, again, of our secondary side, which is much higher, obviously, because it's 208 volt. So we're up to 124.9 amps. Again, we list our 125% rating of that just for convenience underneath. Next, instead of listing kVA, it actually lists your load demand, which will always match your full load amps if you're doing a full capacity calculation for your transformer. However, what this does allow you to do is to modify this. As you can see, it's a white box, in order to choke down your transformer for a specific load. So if you had an 80 amp load or a 100 amp panel, say, you can click on this and you can actually type in your load demand, which will recalculate the entire transformer based on that load demand. Once you do that, this box will turn red to indicate that it has been modified and it's not a calculated result anymore. But for now, we'll leave it at full capacity, which is typical. In overcurrent, you'll notice nothing is listed since we don't have overcurrent protection on our secondary. Let's just quick go over to specs and turn overcurrent on secondary on. Now you'll see in our primary tab that we have 300% rated breaker or fuse overcurrent, and in secondary now we have a listing showing your secondary protection that you will use. And again, it's like we described earlier in the primary section. It'll show your amperage, your fuse, and your breaker, which often is the same and often is different depending on the transformer you're calculating. It'll show the current percentage of your FLA. So right now our fuse amperage is 175, our FLA is 124.9. So we are at 140% of our FLA is our fuse size. And again, it'll show your maximum percentage, which now is 125%. And again, like I said, under the primary section, you're allowed to go to the next common fuse size, and that's why our current percent FLA is always going to be a little bit higher than our maximum percent FLA. The wire section and the pipe section is the same as primary, so I won't go over that again. Obviously, your wire sizing and pipe sizing is going to be larger because you have a higher FLA on your secondary side, but the settings are the same. So you can select between 90 degree, 75 degree wire. You can select copper or aluminum, and everything will be recalculated based on that. Also, you'll see your ground size here, not just bond size. And again, you can set your parallel runs as well. But again, our transformer is pretty small. So let's just go ahead and do a larger transformer. Let's go over to specs, and we'll type in a 75 kVA transformer. We'll go back to our secondary, hide our keyboard. Now you'll see we have substantially larger wire, 400 MCM. So this is a case where we might want to go to a parallel run. So instead of using a single run, we'll go ahead and select parallel run. And now it will recalculate our wire size based on the fact that we're running 2 of each phase, or a parallel run. You can also set your runs up to 3 or 4 runs. But for now, we'll leave it on a parallel run. And that's all your results. So now you have a fully calculated transformer. Now you're ready to do something with it. So we're going to go ahead and we're going to take a look at the main menu and see how we can export or print or do a number of things with our calculated result that we now have here. All right, so let's go ahead and click on the main menu of the transformer module. And as you can see, you have quite a few options here. We'll go through them. Your first option is email. So what this will do is this will take the selected transformer, a single transformer, and it will place it into an email body based on your default email client, and it'll allow you to email your results to someone else or to print them from there, or there's quite a few options you can do from your email app. So this email is actually HTML, so it will be marked up. There'll be color coding in there, as well as font sizing, if your email client supports that. If not, it'll still show up as text, but just plain text. But anyway, that's an option to email the selected transformer. Email as CSV is a little different. What this is doing is it's taking all your transformers for the selected job. So there'll be multiple transformers if you have multiple transformers in the job. And it will save it as a CSV file, and then it'll attach it to an email. What this allows you to do is it allows you to open your calculations into a spreadsheet. And once you're in the spreadsheet, you can do formatting, well, whatever you can do in a spreadsheet. So you can delete columns, add columns, formatting. This will often be handy if you're doing an entire schedule of transformers. You'll be able to email your entire job off as a CSV. And this is a very common file format that you'll be able to open in pretty much any spreadsheet and take a look at all your transformers at once. The help will open up our user manual. It's a PDF user manual that is web-based, so it will open up in your web browser as a PDF document that you'll be able to save. But it's our user manual anyway. Print. Print will obviously print the selected transformer only, so it'll print one transformer, whichever one is selected at the time. This is contingent on the fact that you have a printer, obviously, and that you have proper printer software installed on your phone that will allow you to print. So it's going to attempt to print your transformer. Otherwise, it will show no printer, and you can actually save it as a PDF, print to PDF at that point. But anyway, that'll allow you to print a single transformer, whichever one is selected. Recalculate, we already went through earlier. It's going to clear any of your modified results. It's going to recalculate the transformer. It won't set any settings back to default or change any settings, but it will recalculate any modified settings that are now in red. Reset, however, is going to reset the transformer. So it's going to put it right back to its default state. So it's going to change your voltages, everything, back to a default transformer. So you're not going to use that very often, but it's there if you need it, just in case you've done a lot of modifications to a transformer, say, and you want to get back to square one. Video tutorial, well, I'm sure that one's pretty self-explanatory where you're watching it right now, so that will take you to YouTube and to this video tutorial. And of course, cancel will cancel you out of this menu. I hope you really enjoy our app and that it saves you tons of time. If you require more help, please be sure to check out our PDF manuals and our YouTube channel. Be sure to subscribe to our channel and turn on notifications to keep up to date with new tutorials and apps. Also, check us out on Instagram under Snappy Appz. Thanks for joining me, and I'll see you soon.